Hello, everyone. I'm Ananya Poddar, and I'm a product manager with Watson Discovery. Entity extraction is a key task in business processes today. And with Watson Discovery, we can create entities using a variety of techniques depending on your specific need. We could employ rapid human in the loop customization tools such as dictionary and pattern induction. We can define a regular expression, or we can train a machine learning based entity extraction model. In this video, let's deep dive into the steps needed to build a machine learning based entity extractor. To start off, we first define our entity extractor while importing the documents we want to use to train and evaluate our model. Second, we define the entity types that we want to extract and label examples for each type using features such as bulk labeling and suggestions that utilize active learning based techniques to help speed up this process while ensuring labeling consistency. Next, we train and evaluate this model, and this step is typically iterative. And finally, we apply this model to our collection and visualize the outputs on our documents. All of this can be done in a single unified workflow within Watson Discovery. Now let's jump in to the Watson Discovery tooling UI, where we will build a custom entity extractor to extract the car details as well as reported symptoms from this pre-ingested NHTSA complaints dataset. Now let's start building the entity extractor by first defining it and adding in a document title as well as the text field that we would like to label. The document import can take a few seconds. Meanwhile, let's define the entity types that we want to extract. Now let's label examples of a car defect symptom. After labeling an example, I can choose to enable the bulk label here. With the bulk label, the system will find every other occurrence of the example in this document and label those for which it has high confidence. We can also choose to review these bulk labeled examples in the menu. Alternatively, we can select the bulk label toggle here to keep it enabled across examples in this document. We can also choose to bulk label this example across all the documents in the training corpus in which it occurs. This helps us speed up this process while helping us maintain consistency during labeling. Once we have completed labeling a document, let's mark complete as it ensures our document annotations are included in the training or evaluation set of the model. Now that we've labeled a few examples, the system has started suggesting new examples to consider. We can review these suggestions on this panel and accept or reject as applicable. We can do a quick status check of the documents that have been completed, are in progress versus the ones yet to be started on this panel. We can also use this panel to skip over the documents as needed, as well as add more documents into the train and evaluation set from the collection. Once we have labeled about 20 documents, let's train an initial model. We can adjust the train, test, and blind splits of the data to the model in the advanced options here. Now that the model training is complete, here I can see the high-level evaluation scores, as well as dig in by the entity type. Understandably, the scores are lower at this time since we only have a few examples per entity type. So let's go back and label a few more documents and ensure that we labeled representative examples, especially for those types with fewer examples so far. Once again, let's use a combination of suggestions as well as bulk labeling to create additional training data for our model. Now that we've labeled a few more documents, let's retrain our extractor. Once the model training is complete, let's evaluate our extractor. We can already see a boost in the accuracy with the additional training data. And in this view, we can take a look at the score history over the multiple training iterations. Next, we can take a look at the performance breakdown by entity type in this view before we dig into the qualitative analysis of the performance of this model on the test dataset. Here, we can see the differences between the model prediction and what we've annotated as a ground truth for our extractor on the test data. The model performance looks promising so far. Once we are happy with the accuracy of the model, let's first publish this extractor as an enrichment and then apply it to our collection. Once the processing is complete, applying this enrichment will automatically extract these entity types from our collection, while also creating a facet for the predicted entity types on this view. In this way, we can build an end-to-end entity extraction model all within Watson Discovery. Thank you for watching this video. Please go ahead and try out this feature for your use cases and give us feedback.